All right, so during class today, we looked at this problem, and really the core idea here is that these two students made some major mistakes, and we're looking for some advice for them. So go ahead and pause the video and just try and decide what are some of the mistakes that what are the major mistakes that each of these students made. All right, so just taking a look here at Jordan's work, we want to notice that, hey, we've got 2 times x minus 4 quantity. All of that is being squared, or raised to the power of 2, and then plus 5. And so it looks like what Jordan did is he just originally distributed these values, this 2 inside. And that kind of is a bad deal. That's a bad deal because we can't distribute until we address that exponent. So that's really the mistake that Jordan made. And when we look at Emery, it looks like Emery got the same equation, but he took that exponent of 2 and distributed it. And we cannot distribute exponents. We can distribute things in front, but we can't distribute exponents. And so the core idea here is that if I want to rewrite this thing, the major thing that we need to be able to do is to say, hey, y equals 2 times x minus 4 quantity squared plus 5. Really, that's 2 times x minus 4 times x minus 4 plus 5. And this is really a matter of order of operations in order to simplify it. We will probably need to FOIL this, so we get 2x squared minus 8x plus 16, and I'm going really quickly through this because we talked about it in class, and you know how to FOIL. Like, the purpose of this is not to distribute, but to really understand where this is coming from, and then to distribute this 2 to everything. So we get 2x squared minus 16x plus 32, and that's really just 2 times x squared is 2x, 2 times negative 8x is negative 16x, and 2 times 16 is 32 plus 5, and then we can combine those like terms. So the most simplified version would be 2x squared, because I'm just copying, minus 16x, because I'm just copying, and then 32 plus 5 is 37. So this is the most simplified, and this is something called standard form. Well, standard form, we've been talking a lot about vertex form, and we really want to get into standard form. And so there's a general way of doing this, and this is a little bit tricky, but it's just like what we did. So we're going to take this, and we're going to say A, and then stuff plus K. And inside this thing is x minus h times x minus h. And that's what x minus h squared is. We have to distribute that, so I'm going to copy almost everything else down. A, parentheses, plus k, and x times x is, I'll do this in another color. I'll do it in, maybe I'll do it in red. So x times x is x squared. X times negative h is negative hx. Negative h times x is negative hx. And negative h times negative h is positive h squared plus k. And then we can really combine like terms here, yeah? So I'll do it again. So y equals a times x squared minus 2 hx's plus h squared plus k. And now I have to distribute this a. So a goes to x squared, so we got ax squared, and then a times that stuff, so negative 2ahx. And I kind of squeeze the a in the middle, but it's all multiplication, so the order of the multiplication doesn't matter. And a times h squared, so plus a h squared. And then we got that plus k coming along for the ride, and the y equals coming along for the ride. All right, so this looks kind of wonky, but what we're going to do is we're going to think about this in terms of 3 parts. And in class, I had you underline these 3 parts, and this does not include that x, and then this third part there. And this is going to be really handy moving forward. So this is what we got before, and knowing that we know about standard form. Standard form is something that you talked about in your previous classes a lot, and the variables in there are a, b, and c. And so if we compare this to the thing that we just got by multiplying out the vertex form, well, a is just a, and that's really handy. A is just going to be A. Here, we'll add that. A is just A. And B, the stuff that B is this negative 2AH stuff, because it's the stuff, the B is the stuff that comes before the X. And the C stuff is all of the rest of it. So the C is this AH squared plus K. Now, the thing that we're really going to focus on, and the thing that I really want you to understand, is this middle stuff right here. Because if I take this, what we've been working with is in vertex form. We know that this H is the X coordinate of the vertex. And we're going to move on to the next slide here, actually. This H is the X coordinate of the vertex, and I even wrote that here. And the K is the Y coordinate of the vertex. But here, we've got the A and the B part of the standard form, and it'll tell us H if we have H solved for. So we actually have to divide both sides by 2A, divide by negative 2A, and the A's cancel out, the 2's cancel out, the negative cancels out, and I'm left with H is equal to negative the fraction B over 2A. And that's critical. This, my friends, is like the whole enchilada of this whole thing. This is the biggest piece of this, because when we have standard form, we know the B, we know the A, and we can use this formula to find the X coordinate of the vertex. And I'll show you that right now. So we've got the formula that we had before, and now we have something in standard form. And there's an invisible one there, because if it was anything other than 1, it wouldn't be quadratic. So if A is 1, the A value is 1, the B value is negative 6, and the C value here is 10. And we're going to use the formula that we came up with, this negative B over 2A, is negative B. Well, what's B? B here is negative 6. It's the negative 6. We've got to substitute it in. So there's this kind of double negative going on. There was an announcement, and I just had to address it. So, and then the 2 times A. Well, A is 1. And now we've got this negative, double negative biz going on. So negative 6. Well, double negative is a positive, so that's 6 over 2. And that as a fraction that simplifies to 3. So the H value, if I'm thinking about the vertex is what I'm looking for. The X value of the vertex is 3. And we can use the X value to find the Y value. And that's always been true if we have a function with a formula. So we've got f of 3 is what we're looking for, because that'll tell us our Y coordinate. So 3 squared minus 6 times 3 plus 10. So 9 minus 18 plus 10. So we get negative 9. Plus 10, so 1. So our Y coordinate, when the X value is 3, is 1. And that tells us our vertex. And that's really what we're after, is if I have standard form, I can determine the vertex. So go ahead and pause the video and try this one out. I really want you to give it a shot, and it'll magically appear in about 10 seconds. And the power of video, go ahead and if you need to pause to see how this happened, the vertex would be at 4 and negative 11. All right, so here we're kind of extending this idea of finding the vertex. So you might want to pause the video again, work to find the vertex, and try it out, and then we'll talk about the line of symmetry and the y-intercept and that and whatnot. So I'm going to go ahead and get started. So H is equal to negative B over 2A, and so that's negative 4 over 2 times 1, because A is 1. So that's 4 over 2, and so the X value of the vertex is 2, and the Y value is what happens when I plug it in. So the K is going to be the same as f of 2, or 2 squared minus 4 times 2 plus 8. So 4 minus 8 plus 8, which is really just 4. So my vertex has an x-coordinate of 2, so the vertex has an x-coordinate of 2 and a y-coordinate of 4. So we're going to plot that right on the grid. The line of symmetry always goes through the vertex. And so here I'm going to draw it in green on my line, and it's drawn, so it's imperfect, and that's the line is x equals 2, because it's the vertical line of x equals 2. Well, the y-intercept is a little interesting. Everything up and down the y-axis, the x values are 2. So one option is to plug in, find f of 0, because if the x value is 2, it's going to be the y-intercept. But just notice that every time, if it looks like this, if x is 0, 0 squared is 0, minus 4 times 0, well, that's 0. My y-intercept is always going to be this c value. And so this c value is actually the y-coordinate, so 0, 8. 0, 8 is the y-intercept. And this symmetric point, this is really not something that you need to write down, but just parabolas have symmetry. And so whatever's on the left side of the line of symmetry is the same as what's on the right side of the line of symmetry. And if this is 2 away, then on the other side, there's a point somewhere over here that's also 2 away. And when I say 2 away, it's even though it's just one box, it represents 2 units, right? Because each box represents 2 units. And so once I have that line of symmetry, you can start, I should do this in black. You can start graphing, so long as your parabola goes through those points, and my graph is very imperfect, right? But it's the idea that matters, that you kind of get this generic understanding of the shape, and you can use it to estimate things. So here's a last problem. It'll magically appear in 5 seconds, but I want you to just try it on your own first, and then check it as you go. And real quick, you can't use this graph. It's not the right graph. Now that I have all of these points, including my this symmetric point, which is exactly 3 away but down 1, and exactly 3 away but down 1, then we can graph the curve and get a good estimate of what it would look like. As long as it goes through all 3 of those points, it works. Thanks for watching the video. I know this is a long one, but this is kind of critical.